Okay, so this video, again, we're looking at simultaneous equations and solving them, but just these ones are a little bit trickier because you've got to do some rearranging to get them into the form that you want. What I mean by that is we saw in the previous video, if you watch that you want your in this case, your x parts to line up, which they do here. You then want your y parts to line up, which they don't here. Okay, so it's really important that in this case, right, you want to have, because we're looking at an x and a y variable, you get an x part, either plus or minus a y part is equal to a number part. Okay, so in that kind of format, because then you can cancel them really easily. Here we don't have that. We've got this bit is good, these bits here match up, these bits here don't match up. I've got a number and a y part, and then I've got a y part and a number part. It's all mixed up, which is not good. So I've got to do some manipulation here. So let's just begin by looking at this first equation. 3x is equal to 7 minus 2y. Right, if I just, let's write it over here. So we've got 3x, actually let's write it down here. So this one here, I've got 3x equals to 7 minus 2y. Really, I want to get the y parts, so this minus 2y, onto the left-hand side of the equals, because then it will be clearer, as you'll see in a second. Right, how do I get that minus 2y onto the other side? Opposite of minus 2y is to go and add 2y. I don't have to change to blue there. Add 2y onto both sides. So let's go and add 2y onto both sides of the equation. Right, and that is good, because then these two here eliminate, they cancel, they make 0. And on my left-hand side of the equation, so to the left of the equals, I've got a 3x plus 2y, which I just write as 3x add 2y, is equal to, the 7 is still there, which is good. So the 7 is still there, which is good. And this is good, right? Because now this equation is the same thing as this, but it's in a better format, as we will see in a second. I've got 3x plus 2y is equal to 7. Okay, let's just go and call that equation 1. It's exactly the same thing as this. I've just rearranged it, okay, by basically adding on 2 y's to both sides. And let's call this one equation 2 down here. Keep it exactly how it is, but this is good because I've now got 4x. I've got 4x, take away 3y is equal to 15. Okay, and this is good now because, right, I can clearly see, and I'll highlight it, I've got my x parts that match up nicely, I've got the y parts that match up, I've got the number parts that match up. It's all formatted nicely, okay, which is really good. So that's good. Let's get rid of these highlighters. I don't want those in there. Oh, sorry. Okay, good. So now I can now solve these equations the same way I did on the previous video. Okay, so let's go and do that. Right, but what is the issue I've got here is, well, the numbers in front of the x parts here are not the same, so I've got to make them the same, and the numbers here are not the same. So I choose either to make x or y here the same. Let's go for, I'm going to choose to make the x parts the same because they're positive. It might be a little bit easier, but it is a choice. You can make the y parts the same. It is a choice. Right, to get 3 and 4 to be the same number, well, the lowest common multiple of 3 and 4 is 12. So to get 3 to become 12, let's times this equation here by 4. Let's times equation 2 by 3. Okay? Because, and I'm going to have to kind of write this below here now. Right, 4 times 3x is equal to 12x. I've then got 4 times 2y is plus 8y. 4 times by 7 is equal to 28. So I've times the whole equation by 4, which is, this stuff now is the same as the previous video, okay? And because I've changed equation 1, I've times it by 4, let's call it something new, like equation 3. Okay, and then similarly, 3 times equation 2, so 3 times 4x is 12x, which is good, because now these 12x's, they line up, which is good. 3 times by minus 3y is equal to minus 9y, and that is equal to 3 times by 15, which is 45. And again, because I've changed equation 2, I've times it by 3, let's call it something new, like equation 4. Just to make sure, right, we don't get anything mixed up, let's just make a bit of a barrier between these equations here. Okay, I don't want to mix anything up here. Good, but this is now good because these parts here have the same number in front of the x parts, which is good, so I can cancel them, not by adding them, because 12x and 12x will be 24x, which is not good, by subtracting them. And I can do either 3 take away 4 or 4 take away 3. I'm going to go for 4 take away 3, just because this bit at the end will be positive, but it's up to you. So let's go for here 4, take away equation 3. So 4 take away 3, well 12x take away 12x, they're going to cancel, which is the whole aim of the game here. We're trying to eliminate either an x or a y variable, and these eliminate, that is good. I've then got equation 4, so this minus 9y take away 8y, well minus 9 take away 8 is equal to minus 17, so I get minus 17y is equal to 45 take away 28 is 17 plus 17. So minus 17 times by what is equal to 17? Equal to minus 1. Minus 17 times by minus 1 equals to 17. Okay? So that's good, right? That is my first solution, which is good. Let's go and highlight it. There we go. Okay. To go and find x, I've now got to go and substitute in. I've got to go and substitute y is equal to minus 1 into any equation at all. Right, let's just go for equation 1. Okay, so this one up here, into equation 1, and to find our x value. So it's going to be 3 times x, 2 times y, where y is equal to minus 1, okay, and that is equal to 7. So 3x, 2 times by minus 1 is minus 2, is equal to 7, and then we're trying to find x here, so we can, either you can see it or you can rearrange it. I'm trying to find x, let's get rid of that minus 2 by adding on 2 to both sides. Balance method, solving an equation. These cancel. So I've got 3x is equal to 7 plus 2, which is equal to 9. 3 times what is equal to 9. X must be equal to 3. And that there is my second solution. And as always with simultaneous equations, definitely check our answer. So let's go and check our working. Quite a lot of working going on here. Okay, this is not, getting a little bit higher level now. Let's check our working, particularly because there is a lot of working on going out here. So we've got to go and put y is minus 1, x equals to 3 into any equation. Let's put it into equation 2, okay, just to check it. So hopefully, 4 times by 3, so 4 by 3, take away 3 times by my y value, so 3 times y is equal to minus 1. Hopefully it equals to 15. If it doesn't, we've made a mistake. So 4 times 3 is 12. Minus 3 times minus 1 is plus 3, which indeed equals to 15. So good, my solutions are valid. Good, y is minus 1, x is 3. Good, okay, moving on. Again, right, the issue I've got here is, right, 2x plus 3y is equal to 7. That kind of is in the format I want. I'm trying to get, usually, right, if it's in terms of x and y, it's going to be x plus or minus y is equal to the number part. Right, that's kind of the format I'm going for here. And this is good on the first one. The second one, it isn't that great. So let's just consider this equation. Let's just put it down here. So 4y is equal to 3x, add 15. How do I get the 3x onto the left-hand side of the equation? Well, I can take away 3x from both sides to get it onto the left-hand side over here, because then what happens with these guys, they cancel because they're opposite. Balance method. Right, I'm going to write this. This is 4y take away 3x. You could write it like that. Right, I'm not going to because I want the x part to come first. Right, so I'm going to write it as minus 3x, add 4y is equal to, these guys are cancelled, equal to 15. I've done that because, right, you want your x part really to be first. It will make it a lot clearer. Definitely. So that's good, right? I've rearranged this equation to look like this. Let's keep the first one the same, and let's write it again over here. So 2x add 3y is equal to 7. So I've kept this equation here. Let's go and call it equation 1 exactly how it is. And I've just rearranged the bottom one to give myself minus 3x add 4y is equal to, let's make it a little bit neater, add 4y is equal to 15. Okay, and it's still just equation 2, I'm going to call it. This is now good because I've got the x parts, the y parts, the number parts lined up, which is good. The issue I've got again here is, right, another trickier one because the coefficients here are not the same, and they're not the same over here. They're not matching. They've got to be matching. So either I can make the x parts the same or the y parts the same. It is a choice. Let's go for, in this one, let's go for the x ones to be the same because why not? So what number do 2 and 3, I know it's minus 3, but think about it as 3 go into. They both go into the number 6. So let's go and times equation 1 by 3. And let's go and times equation 2 by 2. because then what's going to happen here, let's put a bit of a barrier so we don't get confused with all of our working. 3 times by 2x is 6x. 3 times by plus 3y is plus 9y. 3 times by 7 is equal to 21. Good. That's equation 1 times by 3. I've changed it, so call it something new, like equation number 3. Equation number 2, I'm timesing it by 2. 2 times by minus 3x is minus 6x, and this is good, because then these x's here, they've got the same number in front of them. 2 times by plus 4y is plus 12y. Sorry, plus 8y. And that is equal to 2 times 15 is equal to 30. And again, I've changed equation 2. Let's go and call it something new, like equation number 4. Well, how do I get a 6x and a minus 6x to cancel out? This time, I do not subtract them. If I did 6x or 6 take away minus 6, it would actually equal to 12. I've got to go and add these. So like in the previous video, right, we've got different signs here. We've got one as a plus, the 6x, one as a minus. You need to add them to cancel them. So it's going to be equation 3, add equation number 4. So if we add those together, the x parts are going to eliminate, which is the end of the game. They become 0. If I add them together, the y parts, I've got 9y add 8y, which is 17y, is equal to 21 add 30, which is 51. Okay, and 17 times by what is 51? 17 times by 3 is equal to 51. So that is good. That is my first solution. Okay, let's highlight it. There we go. Good. How do I get my x value? And I've got to go and substitute in. So substitute y is equal to 3 into any equation. Let's go for equation number 1 because the numbers are a little bit smaller. So I can go and do 2 times x, sorry, 2x, I don't know what x is yet, plus 3 times y is 3. So plus 3 times by 3 is equal to 7. So 2x, 3 times by 3 is plus 9 is equal to 7. I'm trying to find x here, solving an equation, that's balance method. I can take away 9, which is good because then what happens here, these eliminate. Good. And I've got 2x left over is equal to 7 take away 9, which is minus 2. 2 times by what is minus 2? 2 times by minus 1 is equal to minus 2. So that is my second solution. And definitely what we're going to do here is we're going to check our solutions. Okay, that is very important because we might have made a mistake somewhere. So let's check by putting in our values, which are x is minus 1, y is equal to 3 into any equation. Let's put it into equation number 2, just to mix things up a little bit. So minus 3 times by my x value, which is minus 1, add 4 times by my y value, which is 3, should be equal to 15. So minus 3 times by minus 1 is equal to plus 3. 4 by 3 is plus 12, and it indeed equals to 15, which is fantastic. There we go. Okay, they are my two solutions. X is minus 1 and y is equal to 3. I'm just thinking it's quite a long video already. Do I want to give you guys 2 examples? Yeah, why not? Okay, pause video. I'll go through these ones quite quickly because the video is going to get quite long otherwise. But give these a go. Fast forward to the end to see the answers, and you can always rewind to see the answers. Okay, hopefully you've had a go at these. Let's go through them. Okay. Right, what's the first issue here is, again, because we've got x and y here, you really want to have it in the kind of form an x part plus a y part is equal to a number part, which I do not have. Well, on the first one, it isn't the case. Right, so what I need to do here is I've got x minus 4 is equal to y. I want to get the y on the other side, okay, and the minus 4 on the other side. Let's just do it one step at a time to make it clear. Let's get the y over here. I've got to go and take away y from both sides, because then what happens there? These are going to cancel to make 0. And I've got x, and you could write this however you want to, but I'm going to write it as x subtract y subtracts 4. You could have written it as x take away 4 take away y. It doesn't make any difference, is equal to, these make 0, because y take away y is equal to 0. It's getting better, kind of. I've got an x and a y part. I want this number part to go over onto the right-hand side. So to get the minus 4 over, let's go and add on plus 4 to both sides, because then what happens there? Well, these guys are going to eliminate, which is good. So I get x minus y being equal to 0 plus 4, which is 4. And that is now good because I've got, right, x minus y is equal to 4. I've just rearranged this to look like this. They are the same thing. I've just manipulated it, I've rearranged it because now this is good. If I write the second one below it, I've got the x parts match up, I've got the y parts are matching up equal to the number parts matching up. And that's called an equation 1 and equation 2. And these ones are nice and easy to solve because the x parts have got the same number in front of them, which is 1 in this case. So to cancel these guys out, let's go and subtract one from another. So you could do 1 take away 2 or 2 take away 1. It's going to be easier to do 2 take away 1 because then this part will be positive and it's just better. So x take away x, they eliminate, which is the whole aim of the game. There you go. 3y take away minus 1y is plus 4y. Right, 3 take away minus 1. 3 take away minus 1. That goes to a plus, doesn't it? So 3 plus 1, which is 4y, is equal to 12 take away 4, which is equal to 8. 4 times what is 8? 4 times 2 is 8. So your first solution is y is equal to 2. How do I find x? I've got to substitute my y value. So substitute y is equal to 2 into any equation. It's a choice. I'm going to go for equation number 2. Actually, equation number 1, numbers are smaller. So let's go for that one. So I've got my x value, which I'm trying to find. Subtract my y value, which is 2, is equal to 4. So what take away 2 is equal to 4? X must be equal to 4. 4 take away 2 is 4. Sorry. God, no. 6 take away 2 is 4. Apologies. I'm recording this quite late, getting a bit tired, but it's all good. Right, hopefully it is useful. X is 6. Right, let's definitely go and check our working here. Okay, particularly after that mistake. Let's check our work. Right, put in your values y equals 2, x equals 2, 6 into any equation, and it should make sense. Let's put it into equation number 2, which is the same thing as this over here. Okay, so my x value is 6 plus 3 times my y value, which is 2. It should equal to 12. Indeed it does. 6 add 3 times 2 is 6. It equals to 12. So I'm definitely correct with my two values, which is good. Okay, last but not least, 17 minutes in, not too bad. Again, I want to get it in terms of an x part, a y part equals number part. If I look at this equation number 1 to begin with, just to rearrange it to get it into this form, well, it's pretty close, right? I've got 2x. Let's write it over here. So equation number 1, yeah, let's write it like this. Equation number 1. I've got 2x add y minus 18 is equal to 0. Well, I want to get the number part onto the right-hand side of the equation, like up here. Okay, so I've got to go and add on 18 onto both sides over here, because then what happens here, these cancel, which is good, and I've got 2x plus y is equal to 0, add 18, which is 18. Good, I've now got an x part plus a y part, like up here, is equal to a number part. That is good. Okay, what about equation number 2? It's not in a good form at all, so let's really look at this one. I've got 3y is equal to 7x plus 18. Right, I definitely want to get the x part onto my left-hand side. Let's go and subtract that 7x from both sides to, well, eliminate these over here. And then, right, I've got 3y take away 7x, which I write out like that for the time being. Right, take away 7x is equal to, these go, and it's got 80 on the end. Right, 3y take away 7x, you can write as minus 7x plus 3y. It means exactly the same thing. It's a bit like saying, right, if you have, I don't know, 5 take away 3, which is equal to 2, that's the same thing as putting the minus 3 bit first and then adding on the 5. It is equal to 2. They are commutative. The same thing going on here. I can just write it with the x part first. I can write it as minus 7x add 3y being equal to 80. And this is now good, right, because I've got an x part, a number part, sorry, an x part, a y part equals to a number part. So that is really good. So equation 1, I've now rewritten as this one down here, as 2x add y is equal to 18. And then equation number 2, I've rewritten it. I've just rearranged it. I haven't changed it at all, as minus 7x add 3y is equal to 80. Okay, but it's still equation 1 and equation 2. I've not changed it, I've just rearranged it. Okay. This one's a tricky one again, because right now I've got something that we're familiar with, but your coefficients, your numbers in front of either the x or the y parts are not the same. They've got to be the same, so either make the x or the y parts the same. It's going to be, the easiest option here is to make the y parts the same, because if I times equation 1 by 3, I get 3 times y is 3y. It matches this one straight away. So let's go and do that. So 3 times 2x is 6x. 3 times by y is plus 3y. 3 times 18 is equal to 54. There we go. And because I've changed equation 1 now, I have times it by 3. It is a new equation. Let's call it equation number 3. And keep equation number 2 exactly how it is, because I've got minus 7x. I've got that plus 3y, which matches with the one above, which is equal to 80. Okay, and let's just make a bit of a barrier again so we don't get confused with all of our working. Right, how do I eliminate the 3's in this case? I've got to subtract them, haven't I? So let's go and do equation number 2. Take away equation number 3. So number 2, so minus 7x take away 6x is going to be minus 13x. 3y take away 3y is 0. They cancel, that's the aim of the game. There you go. And that is equal to 80 take away 54, which is equal to 26. Okay, minus 13 times by what is equal to 26, and it's going to be equal to minus 2, because minus 13 times by minus 2, two negatives multiplying to make a positive. That is my first solution there. Okay, x is equal to minus 2. I'm not finished, I've got to find y still, but I can find this nice and easily now by substituting in. So substitute my value, which is x is minus 2, into any equation, and again it's a choice here. Let's go for equation number, it can be any of these, it doesn't make a difference at all. Let's go for this equation number 1, right, written in this way. So 2 times by my x value minus 2, add y, minus 18 is equal to 0. So 2 by minus 2 is equal to minus 4, add y minus 18 is equal to 0. Minus 4 minus 18 is minus 22. So I've got y minus 22 is equal to 0. Add on that 22 to both sides. So y is equal to 22. Okay, so that is my second solution. There we go. And this one was a tricky one, so definitely check our working. Let's do it down here. Let's check our work. So when x is minus 2 and y is 22, let's put it into equation number 2, just to mix it up a little bit, and hopefully it makes sense. And it can be any equation, doesn't matter, in any form. Let's go for this one. So hopefully 3 times y, so 3 times y, which is 22, it should be equal to 7 times my x value, which is minus 2, add 80. So 3 by 22 is 66, and that should be equal to, that's minus 14, add 80. So 66 should be equal to minus 14, add 80 is indeed equal to 66. So there we go. Check my work, and it's all good. So that is solving harder simultaneous equations. Okay, hopefully it was useful. And as always, if you need to rewind at any point, you can do that. Okay, and that's it. We'll go on to kind of wordy simultaneous equations in the next video. Thank you.